Hello everyone, welcome to Ultimate JS. Today we're going to solve another question called maximum area of island. So the question suggests you are given m cross n binary matrix grid. Binary matrix grid means all the values in that particular matrix will be 1 or 0, right? The island is a group of ones representing lands connected by 4 directionally. Okay, so the ones will be connected with each other with in 4 direction, like up, down, left and right. Okay, then you may assume all 4 edges of the grid are surrounded by water. Okay, so what it says that we can assume the 0 are like water and the ones are like land. Okay, so and if every one unit is 1, then we have to calculate the sum of the connected ones and return the max value. Let me explain this on whiteboard. Let's assume that we have this matrix that consists of some rows and some columns, m cross n, right? So now, as far as the question, we have ones and zeros. Let's consider 1, 1, 1, 1, 1. Everything else is 0, and we have 1, 1, 1, 1, 1. No, okay, 1. Maybe these are disconnected. Okay. In this particular case, we can consider these zeros are as water, right? Water, and this is land. Once 1 are land and 0 are water. So now it says that every one can be considered as 1 unit. So this is the island because these are the connected ones. So 1, 2, 3, 4, 5 is the maximum area size, and for this one 1, 2, 3, 4, 4, the max size here is 5, right? So our answer should be 5. So how are we going to solve it? So every time we find a 1, right, then we have to check through like right, left, up, and right, left, up and down, all the 4 directions. And then we have to, every time we find a 1, we have to make count plus 1, right? And every time you get a 0, we have to return the value. For example, in this case, it will be like 1, 1, 1, 1, 5. The time we get 0, we'll be returning the value for this, for the down DFS. Then if we get this boundary, you're going to return from this DFS, so on. In every 4 directions, whenever we encounter a 0, we have to return that value, and we keep track of the maximum, right? And we have to change the max value based on the returned value. For 5, 4, then we have to keep comparing those values, and we have to keep saving it. So yes, this is a typical DFS problem, and then let's implement this. So I have created a grid, as you see, 1, 1, 0, 0, 0, and in this particular grid, the max size will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, for this is the the max grid, max island that we find in this particular grid. So our answer should be 12. There is another island over here, like of size 11. So we're gonna keep calculating those values, and we're gonna, at the end, our function should return the max, that is 12. Okay, so like in every DFS, we have to first set our limits. Let's discuss like our, for example, let x limit, or we can say x. I try to assume this like x, because we have to travel in 4 different directions. So I try to I always try to visualize this x, y axis, right, like that. So our x-axis is our rows, that is like grid dot length minus 1, that is our x limit, and then we have to find our y limit. Let y equals to grid 0, the first element's length, minus 1. So we set our limits. Then definitely we have to iterate through every element of our grid. So we need 2 for loops. For let's index, then this is like grid dot length, let's this index as I, and we need another for loop for j, then we need grid dot 0 dot, no, we can make it x and y, right? Y, x and y. So we have our xy limit already, so we can use that. Now every time we find 1, we have to go through our DFS, right? If grid I and j equals 1, then we have to run the DFS. So now we have to write our DFS. So function DFS will take our I and j, and our grid is already defined, so we don't have to send it, but again it will count, yeah, because we will be keep counting the value, so we have to send it. Then yeah, because I am writing this function inside the get max area, so this internal function will always have access to the variable of its parent, so that is grid, so we don't have to pass the grid, but we have to write the base cases. So few base cases here that are common for every DFS, that is like if I greater than equals to x, that is the x limit, or j greater than equals to j limit, right? Or I less than 0 or j less than 0. These are the basic base cases. So now another thing we have to do is, like, if we counter 0, we have to break it. Grid I j equals to 0, and then just like we have to submerge the land every time we land it, otherwise it will go into infinite loop. So we need to create a new grid ij. Let's assign it to 2, okay? And let's assume that whenever we find a 2, it means we already visited that land. So return 0, right? So now how we decide that we visited land? So every time the base case is not true, then we have to submerge that land, right? So grid I j equals to 2. Now then Now we have to repeat our DFSs for all 4 directions. So DFS I plus 1 j count, DFS I minus 1 j count, DFS I j plus 1 count, then DFS I j minus 1 count. But here we have to, every time we get a land 1, we have to add this to the count, right? So no, we don't need count to pass count here. We need to pass count. We have to again we have to keep adding, so we don't need a count here. Definitely it can return, because we are returning 0 here, we don't need a count. And then every time we encounter a 1, right, we have to add this to the process we are counting, the 0 we are counting. So let's do that. So we need to add it, plus 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 plus. So what does it mean? Every time we land at a 1, we are adding 1 to our count, and we are again going to 4 direction. Let me show you on the whiteboard. So what is this logic is doing is, every time we find a 1, right, maybe we find a 1 here, so it's gonna add 1 to our count, then from this position again it will go to all 4 direction. That's what it is doing. So now then we have to add 1, so 1 plus all these counts, then we have to return this. Okay, now for every one we have to call our DFS. So let count equals to DFS I and j. Okay, now we have to keep track of the max, right? So we're going to create a variable max and we're going to give it to 0, and every time we count we have to assign max to math.max of existing max plus the count we get, right? Count we got. At the end of the function we have to return the max value. So yep, this should do the trick, and let's try to run our test cases. So our test cases takes this grid. If you see in this grid, the max area is 12, so it should return 12 to us. So now let's run the test case. Oh, there is a bug. This should be y, because our j limit is y. Run test. Return 6. Why? So somewhere it's not going beyond. There we go. So because here there is 2 bugs, right? One is like we wrongfully mentioned the j limit to j, that need to be y, and we don't have to equals to y. Y, by the way, we should have to make only less than, because we already subtracting 1 and making it only the length. So we just have to, because now the x value will be in the range, because we are already subtracting 1, so we don't have to make it greater than equals to, we have to only make it greater than. So that's that. Hope you enjoyed it. Thank you.